need to be a little bit more careful. But, all right, so we're going to work on law of cosines today. And there are three versions of the equation for law of cosines. And the different versions actually, one of them, I should say, actually looks an awful lot like the Pythagorean Theorem, at least part of it. So let me show you the three versions. One of them is that a squared equals b squared plus c squared minus 2bc cosine of angle A. The second one is b squared equals a squared plus c squared minus 2ac cosine B. And the last one is c squared equals a squared plus b squared minus 2ab cosine of C. So if I cover up the minus 2 whatever cosine whatever, if I cover up that part of it, they look a lot like the Pythagorean Theorem. In fact, the last one would be the Pythagorean Theorem, right? A squared plus b squared equals c squared. But you remember, Pythagorean Theorem is useful and only used when I have what kind of triangle? Right. A right triangle. So I could actually use these formulas when I have a right triangle as well. It just happens that when I have these formulas for a right triangle, then I actually have the cosine of 90 degrees. And what's the cosine of 90 degrees? It's 0. The cosine of 90 degrees is 0, which means that last portion that I said, if I ignored that portion, I would be ignoring that portion because it would be worth 0 if I had a 90-degree angle. Is everybody following that? So these can be used at any case, any one of these at any point in time. The things that you should notice, just even if you've got them written down so that you're referencing them, is that the same two letters right here are right here in this multiplication in all of the formulas, right? So if I have a squared and b squared on the right, I also have the times ab. And the angle is separate, so whatever letter I have on this side corresponds to the angle on that side. And all the formulas work that way too. Okay, so those are some key aspects to keep in mind. All right, so let's take a look at how we use this particular situation. So I don't have the values written in here. Let me get them in here. So we have angle A, and it's 67.3 degrees. I have side B, and it's 8.94 meters. And you also have side C worth 7.23 meters. And it says solve each triangle, and you guys know what those directions mean. What do they mean? Find the rest, right? There's 3 pieces I was given, and there's 3 pieces that were missing, and I need to find all 3 of them. Now, I don't really have a choice in which formula to use because I'm given angle A, so I need to use the formula that has an angle A in it, and there's only one of those. So I'm going to use the formula that is a squared equals b squared plus c squared minus 2bc cosine of A. All right, so a squared I don't know. I do have b, though. It is 8.94, and I need to square that. I also have c. It is 7.23, and that needs to be squared. And then it's minus 2 times 8.94 times 7.23 cosine, and I have that angle of 67.3 degrees. All right, so in this particular case, this is very clean. I'm looking for what's on the left-hand side. I've got all the values on the right-hand side. I can put the whole right-hand side straight into my calculator. Be careful, don't miss a parenthesis or open a parenthesis you don't close or forget a plus sign or something like that. But you should be able to enter the right-hand side exactly as it appears into your calculator. And when you do, that will be the value for a squared. Well, for right now, you don't want to round too much because you're going to square root. But after we do our square root, we're going to round to 2 decimal places. Before we do that, though, let's keep 4. What's the value that you got, well, I'm not put that there just yet. What's the value you got before you square root? That is, the right-hand side of this equation is what, with 4 decimals?
82.3095.
All right. And then we want to square root because we are working with a squared, and I actually want to find out what a is. And what do I get?
9.07. Or how?
2 decimal places. That's fine, yeah. And then it's meters, right, Caitlin? Yep. Okay, so this is one of the pieces of information. It's the side. Now, here's where you get a choice that you get to make. You can, well, you have to find one of the remaining angles, and then the third angle will be easy, right? We have to find either angle B or angle C. So you kind of get a choice there, but that's not the choice that I mean. You have a choice between whether you want to use the law of sines or the law of cosines to find your angle. Now, because you actually have a pair that you know now, you know an angle and you know its opposite side. Law of sines is easier to work with than law of cosines. However, you have to be a little bit careful because you don't want to accidentally put yourself back in that law of sines ambiguous case situation that occurred. Remember that? Because there isn't 2 triangles here. There aren't 2 triangles here. There aren't. And so we want to make sure that we're not accidentally making up something that didn't really happen. So you might ask yourself, okay, but how do I make sure that I don't make up something that didn't really happen, right? Well, what you do is you find the smallest side first. So we have 2 different sides over here, right? I have side B, which is 8.94, and I have side C, which is 7.23. Okay, we're going to find the angle that goes with the smallest one. And if you always find the angle that goes with the smallest one at this point, then you can't make a mistake and find something inadvertently wrong. So I'm going to find the angle that goes with C. Okay? So because this is smaller. So I want to use the smaller one. All right, so I'm going to set up a law of sines problem. I have the side measurement for side A, which is 9.07. And that needs to be divided by the sine of the angle measurement for A, which was 67.3 degrees. I have the side measurement for C that was given to me at 7.23 meters. And I want to find the angle for C, so I have sine of C written below. Okay. You've done this before. You had a whole lesson, right, where you were doing, I don't know, you probably did this 40 times between your My Math Lab and your work on your book. So what are we going to do? Cross multiply, you bet. So I have 9.07 sine C equals 7.23 sine of 67.3 degrees. And then what? Right, divide by 9.07. That leaves me with sine of C on the left. What value do you get on the right? 4 decimals. 7.23 sine 67.3 degrees divided by 9.07. Did we get that? Okay, great. And then how do we find angle C? Arc sine or inverse sine, yes. So we do inverse sine of, there's a point there, you can't see it very dark, sorry, 0.7354. And I will get an angle measure of what? 47.3. And of course we are using 1 decimal because this is an angle measure in degrees. We talked about that before. 47.3 degrees. Piece number 2. Piece number 3 is easy. What do I still need to find? Angle B, and how do I find angle B? Subtract. So I have 180 minus 67.3 minus 47.3. And what is angle B? Awesome. Okay, so one problem that we just did, you're given 2 sides and an angle, and none of them match up. That's how you know you have to use law of sines, or law of cosines. Law of sines requires that you know an opposite angle pair, right? You know an angle and you know an opposite side of it. But in this problem, take a look back again. I had an angle A, a side B, and a side C. I don't have any pairs of things, so I can't use law of sines. So I have to use law of cosines. Okay? Now there's one other case where you have to use the law of cosines, and that's problem number 2. So what do you notice when it's describing problem number 2? They're all sides are given. So clearly you can't use the law of cosines because the law of sines, keep saying I'm wrong, because the law of sines involves every angle in it, right? You have to know an angle to use law of sines, and we don't have that. So I have A is 42.9 meters, B is 37.6 meters, and C is 62.7 meters. Okay, so you get to choose again which angle you want to find first, and it doesn't really matter. However, if you want to just make sure that you're not going to get anything weird going on later, we're going to choose the largest angle this time. We want to use the smallest angle with law of sines. That keeps us safe. And if I use the largest angle with the law of cosines, also going to keep me safe. So how do I know which angle is going to be the largest? Do you remember from geometry?
Which side?
Yes, the largest angle is across from the largest side. That's a geometry concept. So I'm going to find the largest side here, and the largest side is C, right? So I'm going to find angle C first. So I'm going to use the formula that has angle C in it. It doesn't really matter. If you had found, let me just back up for just a second. If you decide to find angle A or B first, it's going to be okay. You're not going to get the wrong angle for angle A or B. That's not going to happen. But if I go ahead and find angle C here right now, then when I use the law of sines in a little bit later, then I don't actually have to be careful because I've already determined that if there was a obtuse angle, I already found it. Because angle C, if there's an obtuse angle, it has to be angle C because it's the opposite the largest side. So that's what's happening here. All right, so I've got C squared equals A squared plus B squared minus 2AB cosine of C. That's the one I'm going to use. I know C, it's 62.7 then squared equals A, which is 42.9 squared, minus B, which is 37.6 squared, minus 2 times,
Is that plus or plus?
which one?
Between the A and the B.
It's plus between the A and the B. It's a minus for the 2 part at the end.
Yeah, you know that or minus the first half.
Oh, right here. I'm sorry, I was looking at my formula that I wrote down. Thank you, Lauren. Yes, there's a plus there and then the minus next. Thanks. All right, and then I have minus 2. We have side A, which is 42.9, and side B, which is 37.6. And then I have cosine of C. Now, this is not as easy to work with your calculator. It's not horrible or anything, I'm not saying that, but it's not as easy to work with your calculator because you don't have all of one side all with numbers, right? I actually have angle C on the right-hand side with a whole bunch of other stuff. So you have to be a little bit careful. So somebody tell me what 62.7 squared is.
3,931.29.
Okay, did I get that right, Erica? Is it 3931.29? I heard you right. Okay, great. The next thing we're going to do is we're going to find these two that are squared and added together. Okay? So square the 42.9, square the 37.6, and add those two together. Sure. Yeah, do you have it, Janet?
3,254.27.
Okay, great. And then we're going to do the same, do this one more time. I'm going to multiply, or you're going to multiply 2 times the 42.9 times the 37.6. And that is times cosine C, right? Okay, the reason I had you do that is not because you have to necessarily do it in this many steps, but because what I want to point out to you is a common error that I hesitate to say it, but I imagine that several of you would make. Some of your math backgrounds with algebra are a little weaker than others. What you can't do is you can't combine this 3254.17 and the 3226.08 on the right-hand side. You can't combine those. I can't just subtract those and then continue with the problem. Why can't I combine those? One of them is multiplied by cosine C. Okay, the cosine C is the variable in the problem, and I can't combine terms that are not alike. One of these terms has a variable in it, and the other one doesn't. But what I can do is I can subtract this 3254.17 over to the side with the 39. So what is 39, 31, 29 minus 32, 54, 17? All right, and then I still have the negative 32, 26.08 cosine C. Now what?
Divide by negative 3,226.08.
Exactly, on both sides. Okay, so what I have now found is what the cosine of C is. So what is the 677 divided by the negative 3226?
Negative 0.2099.
Okay. So Lauren's giving me all her values. Did someone else have those values as well? Okay, I'm getting nods too. Awesome. All right, so then how am I going to find angle C?
Inverse cosine.
Inverse cosine, you got it. So I'm going to do cosine inverse of that negative 0.2099. Write that, yeah. And what do I get for C?
I got 77.9. Oh, I forgot the negative.
Yeah, yes. Yes, remember that negative. It will change the value. That's true. It'll put you on the wrong side of the wrong quadrant. Okay, so 102.1?
Yep, sorry.
Okay. All right.
Sorry.
You're fine. All right, so we have 102.1. That's angle C. I need to find another angle, and I could go through all of that again to find angle A or B, right? I could do it again. But I'm not going to, because I actually know an angle and an opposite pair now, right? I know angle C and its opposite side, so I can use the law of sines, and it works lots faster. Okay, it's easier to use. So I tend to try to, save time when I can. At least that's my goal. So we're going to use an angle C and side C. So side C was 62.7 meters divided by the sine of angle 102.1. Now, it doesn't make a hill of beans difference which angle we pick next, because I found the only one that was the biggest one. The biggest one was 102.1. It was opposite side C, so it doesn't matter which of the angles I pick next. So let's just do angle A, and then we would be dividing, sorry, I wrote the wrong thing. Angle A is on bottom. Side A, 42.9, goes on top, and then sine of angle A on bottom. Yes, it would matter. And in fact, in this case, if you found, for instance, angle A first, and then you go and you find angle C next, you will get the wrong value. Because angle C is the largest one, and when you do sine, you'll get the wrong thing. Yes. So you either need to find angle C first or angle C last. That's the deal. You got to find the biggest one very first. In this case with law of cosines, using law of cosines, find the biggest angle. Or you have to save it till the very end and use that one as the last one. All right, so we're going to cross multiply like we did before, right? 62.7, sine A equals 42.9 sine of 102.1 degrees. We'll divide by the 62.7. And then we'll do our inverse sine. Sorry, I just saw the time and we're just a touch over. I apologize. Let's finish this so that we've said we finished it. What did I get with the 42.9 sine 102 divided by 62.7?
0.6690.
And then inverse sine for that?
42.00.
Okay, so angle A is 42.0. Okay. And then I have side angle B next, which is 180 minus the 102.1 and minus 42. What'd you get for angle B? 35.9 degrees.